You doing? Welcome. It's Monday night, so it is the Physicist and Philosopher Hour. The physicist is Dr. Claudia Albers, and I am, of course, the philosopher. So, Claudia, how are you?
I'm fine, thank you. I was feeling a bit tired today, but I'm okay.
Okay. Probably some planet is in retrograde, I'm sure. Like always sound like that. So I just want to say hello to all of the moderators and everyone joining us tonight. Thank you. We know that you always have a choice, and it's a privilege to have you joining us. So, uh, well, Claudia, we're almost to the end of the year.
Yes,
It
it
has
went by
really,
so quickly, didn't it?
it's like, what happened? You know,
Yeah.
well, I don't know. It's over with. I mean, I tell you, it makes me question, Claudia, at times the whole concept of the consistency of time.
hmm Yeah, I think I actually wrote some articles about that, that I actually think that time is moving faster. But we only aware of it because we get less done. And
Hmm.
we do that because we're spiritual beings, because everything else just accelerates at the same rate that time is accelerating. So even cellular division in our bodies will accelerate. Everything, metabolic rates will accelerate at the same rate that the sun is rotating and the planets move in their orbits faster, but we're not aware of it because everything else accelerates and keeps pace with it. And it does that because the sun is generating more energy.
Hmm.
And it's doing that because there's more energy being pulled from it by the planet X system. So in order to compensate for the energy being pulled from it, it keeps generating more and more and more of it. And that accelerates everything in the solar system. So I think time has been accelerating for thousands of years.
Interesting. So time in its construct, how I view time is the breakdown, as you said, of matter, you know, atoms. And that breaks down, that gives us the perception of time itself. Things progress. But I happen to think you're right. I think that something's speeded up. And sometimes I look at it. I had this conversation recently. Someone was saying, well, how do you say that the planet Earth is changing in its tilt, that the solar system is changing? And I said, well, if you have a point and you keep that point always at center, I said you could be literally like this, but you're going to see center as center.
Mhm.
Would I be correct on that?
Yeah, that's right. I mean, we dependent on the sun because the Earth rotates around the sun. And I actually wrote a couple of papers on this, but what happens is that the rotational rate of a planet, as well as its orbital movement, is orbital rate, is dependent on the gravitational constant, which is dependent on the energy. So the sun has been generating more and more and more energy. So the energy in its particles keeps increasing as the planet X system draws it out. And that increases G, the gravitational constant for the solar system, which then accelerates time.
Would magnetism be impacted by that as well?
Yes,
I would think it would seem like, yeah.
because what happens is the gravitational interaction is what gives rise to the electric interaction in the outer layers of planets. So if the gravitational constant increases, then the electric field, as long as there's energy available, will increase. And with the electric field will go the magnetic field will increase as well.
That's what I was getting to, the magnetic
Yeah.
field. Yep, yep.
As long as there's energy for it all.
I love that.
But as long as the sun has energy, this time will keep on accelerating. That doesn't mean that it's emitting light, because obviously it's not.
And that's
But it still has energy, so it's not dead. It's still pumping out more and more and more of it in response to the debris that the Planet X systems have left with it. And it's gotten to the point where it has no corona, so it can't emit light. But it still has energy.
I have something to show you.
Mm-hmm.
You want to see something?
Yes.
I showed this to the audience on my noonday show, but I'm telling you, Claudia, give me 1 second here. I'm driving the bus at the same time and I'm texting. You should never do that, Claudia. You know that.
Oh, I never do that. I never even look at my phone if I'm driving.
Yeah, I'm the same way, but right now I'm doing two things at once. So, let me show you something here, Claudia. Can you see that?
Oh, yes.
Okay, so
Volcano.
yes, this is Popo in Mexico.
Mm-hmm.
This erupted last night. Now, I know, Scott, you're watching this, my friend, so really would like to get your input. And as I'm looking at this, I can now see where I think this craft is at. Or I think possibly, potentially a stellar core.
Mm-hmm.
Are you ready for this?
Well, I wouldn't be surprised, because they will induce volcanoes to erupt. So
Watch this right here, Claudia.
Uh-huh.
And be prepared to be. Now, the eruption is right here. I
Yes.
want you to see there's nothing up here that could ever reach, this volcano could never reach up here in a secondary imaginary explosion. So watch this, Claudia.
Wow.
All right. So let me explain to you what we just saw there.
That was amazing.
All right.
My
So
goodness.
this is the initial explosion, but here is the weird thing, Claudia. And I'm just going to advance it frame by frame. Something blew up here. You can see that there is two secondary, actually three explosions taking place. One here, one here, one here. Watch. You see this? Are you seeing how it's blowing up whatever the hell this thing is? Now watch.
Wow.
Look at this.
It's being drawn upwards. That's exactly what they expect a stellar core to do. It's drawing the lava upwards towards it.
Well, there's a secondary explosion taking place. This is not even lava up here. The lava's down here. And look at this is behind the lava. This is what really got me when I did the analysis on here. This is a dark core. There is something exploding here, and watch as it continues to explode. Claudia, there is something you see.
Yeah, that does seem.
There, the force is going out here and out here.
Yeah, because you see what happens is they have this gravitational wave that will cause the density of the lava to decrease and then increase. And that will cause it to explode out of the volcano. So they will induce volcanic eruptions. And of course, they're always drawing matter towards them because they have a gravitational attraction for this. So it possibly acquired some of this lava as an atmosphere, and then it reacted with it.
Well, as you can see, the lava has already been pulled back by gravity, but something is.
But some stayed up there. That is amazing. This is absolutely amazing, Wayne.
Watch this.
Because there has to be something up there for it to attach to.
Look at this is huge. Whatever it is, it's right here. But watch this over here. This is what got me. Did you see this? Now
Yeah.
it's a secondary explosion. There's no lava there anymore. There is something going on. Watch this. Did you see that? Look how it's throwing
Yes.
debris off.
Wow.
Look at this. And it's still it's not here anymore. There's something up here that's causing this.
Yeah, I think what happened was the stellar core drew some of the lava upwards and it became attached to it. And then it started reacting with the matter that is on the stellar core itself.
And look
And
at
that's
this
why
guy.
we're seeing this kind of reaction from it.
And it keeps exploding.
It keeps exploding because lava is very hot.
Look at this.
And obviously, and stellar cores are very depleted in energy. And that means even heat, because heat is a form of light energy. So it's drawing energy from whatever makes contact with it. And that, in this case, the lava. So there's going to be reactions.
Well, this is the longest one I've ever seen.
This is amazing.
It's still
it's still up there reacting. I mean, you wouldn't expect lava to just remain suspended in air. It's emitting light. Yeah. So there's something up there, something happening, that's for sure.
I mean, it's I don't know if, I thought, well, could it have been a UFO? If they did, they got whacked. I told them, the audience this afternoon, I said, well, the Mexican army needs to go out and check this out.
Yeah, the thing is, if it had been a ship with lava falling on it and that kind of reaction, you would expect its drives to fail, in which case it would head straight for the ground.
And I wanted to use this in comparison, Claudia, so everyone can see that it's not blowing off to the side. This is a plume that's going exactly like a plume is supposed to go. Mm-hmm. So if we go back here, there's the explosion. And there is whatever is starting to blow up. Look at that dark core right there.
I can almost see that there's an object there. That's amazing.
Thought you'd like to see this.
It's amazing, Wayne. Wow.
Well,
I believe that I'm believing more and more, tending towards that just about everything that's happening on this planet disaster-wise is actually caused by these objects.
You could say, well, it could be a craft, but to me, you can still see it's a solid core. Yeah. But whatever happened over here, and this is, you can see the plume, it's doing just like, So Claudia, this is something you ought to...
I'm sure I should write an article on this because this is amazing.
I think it's really good evidence.
Mm-hmm. Yeah, it is. It's amazing. Absolutely amazing.
So I thought you would like that. And I'll send you this. This is on Global News.
Okay, thanks.
.ca. I wanted to get your comment on this one. So China and Russia band together on controversial heating experiments to modify the atmosphere. I read this, and Claudia, what they're talking about is right here, is superheating the ionosphere.
Well, that's exactly what they are doing already. I'm going to write an article about this, but I haven't yet. I mean,
this is what I wanted to show you. They have now pulled it out to nearly 50,000 square miles. So people kind of get to us all the time saying, well, this simulator theory. My point to that is, ladies and gentlemen, that's 50,000 square miles that they're now able to do a direct beam of some kind, Claudia, to superheat the ionosphere.
Yeah, well, they're already doing that. I believe they're actually doing it to control the objects. They heat the ionosphere, and even below that, the atmosphere, so that the objects are attracted to that region. This is how they're controlling the weather and the earthquakes. They say, oh, we can create earthquakes. Yes, they can, but you know how? They're controlling the objects that are creating them. They've known for a long time that these objects are coming into the atmosphere, and they found a way of controlling them.
Yes. And when the more I got into this, I'm reading, all right, so now they're talking about the sun, and I'm thinking, well, if you have a sun simulator, the ionosphere would be the perfect place to put it. So is this a cover saying you can now superheat up to 375 miles? And I'm going, okay. And now they're talking about large amounts of cosmic rays coming in.
Yeah, but the thing is, they are producing the cosmic rays with the radiation that they're emitting into the ionosphere. And the Earth is, as we know, now a source of cosmic rays because of the energy that the stellar cores are pulling out of it.
I just wanted to show people what they're saying. It's what you've been pointing out to.
This is unbelievable what these people are up to.
This one, I'm thinking, what? All right. I am not a PhD. I'm not a scientist, but talking about putting a craft, a landing craft, in this type, Europa, with basically superheating it with nuclear radiation.
Yeah, right. And that's how you're going to look for life.
Yeah, exactly.
For life by destroying it.
You melt your way down with a nuclear-powered robot. What? Okay. I'm sure if there's life there, they're really going to appreciate that little present. Yeah, here's a little radiation for you guys. It only takes about 10,000 years before you can get close.
Well, I don't believe that NASA is going to Europa with anything at all, because I wrote already about the fact that they said they landed this the rover on Mars. Mm-hmm. And I analyzed the footage, and those people were obviously not mission control specialists because they were acting like actors. So,
listen, I live in a world that every day you have to say, well, now my feet is touching the ground, so I know that's reality. But the rest of it, it's getting very odd. And speaking of volcanoes, here we go. Naples, you're under one that's filling up right now. All around this area, Claudia, well, all around regions in the world, but here we go again. Things are happening around the Mediterranean area.
Yes, lots of things. And it started with all the rain and the floods. And then the little earthquakes and volcanoes erupting. Do you know what that to me means? That there's a stellar core, or they are attracting them to the area and causing these things. Because they know which one of which size is likely to do what. And they know exactly how, and they know they're hungry for energy, for light. So they can control them with light because they have light emitters, energy emitters, radiation emitters, different frequencies, different wavelengths in the atmosphere.
So I want to bring this up for all of us who live in the United States. Had someone I know who was up in the northwestern part of Wyoming, and actually it's kind of coming in from the northwest, moving in kind of mid of the state. The ranchers are reporting, they're calling them sulfur pits. And we're talking vast amounts of distance here. This is primarily horse country, so there are typically very large horse ranches, and the ranchers are saying they're finding more and more of these sulfur pits. Literally, the ground is cracking open, and during the night you can really see it. And across, even with the wind that blows up in Wyoming, everyone's ever visited there, you know what I'm talking about. But Claudia, they can see this blue eerie flame in the sulfur pits that are opening up all over
My,
the place.
that is terrible. That's
Yeah,
not.
you know what the ranchers are thinking? They're
There's a
thinking
volcano under there.
they're thinking Yellowstone. This is
Yeah,
sulfur.
it's close to Yellowstone. I wouldn't be surprised because from all I've been hearing about Yellowstone, I would say that that volcano is getting close to erupting. And I wouldn't be surprised if you had just that fissures opening up all over the place and you're starting to see lava come up here and there. Because this is exactly what these objects do by causing the ground to contract and expand. They'll break up the ground. The lava, the magma from underneath will be almost pulled upwards because it keeps expanding and contracting. So it will find a way through the ground upwards.
Well, it's happening.
It
So
may not be a cataclysmic eruption, but you may start seeing it opening up here and there.
the ranchers think that it's a little bit more than just
That is
they're
very
worried.
that if I were them, I would get out of there.
Well, you know, they can't. This is their livelihood, but
Yeah.
these are yeah, it's something is going on. Now, we talked about on this show about the sound that was hitting Delaware and the Del Mar vicinity on the East Coast, and talking about this consistent hum. In fact, and some people were reporting headaches, eye tremors. Now it's now moved to the Chicago area. This is a sound that they say that it says, even though the noise is subtle, it's been driving some people between Clark and Hay Street crazy. And it's this constant hum. It
Yeah.
becomes weird to me, Claudia,
Mm.
because Chicago is a vast difference. I can tell you exactly how long of a flight it is from Philadelphia to Chicago. I've made it many a time. But here we go. It's happening now in the Midwest. There is this weird high frequency, actually, it's low frequency hum.
Well, one of the things that they will be using in the atmosphere is sonic generators, because I think that's how they are producing some of the lenses out of the atmosphere, where they would use sound waves to produce different density layers and interfaces.
Yeah, can I say something on that?
Mm-hmm.
Do you know what the Pentagon came out with this afternoon? They now admit that Russia and China now have these new generation of, are you ready for this? Hypersonic missiles.
Oh.
Now, I have a postulation for you, Dr. Albers. If these cats are using ionosphere heaters, why wouldn't they be able to use hypersonic weapons on someone 6,000 miles away?
Yeah, we're getting into a whole
I know. But
because the thing is, they have advanced weapons where they put nuclear weapons to shame. Okay, they have plasma weapons that can probably incinerate most of the atmosphere of a planet. They have plasma rifles. They have all these weapons. But yet, the farce war, is done with conventional weapons. They're only the stuff we've heard about.
mm-hmm.
Yeah.
Yep. Well, I just postulate it seems like I was putting some things together. So we had diplomats down in Cuba. They came back to the United States with permanent damage.
Yeah.
And they proved that it was done by sonic weapons.
Mm-hmm.
We get this mysterious hum that, it drives some people crazy.
Yeah, the thing is, the human mind is very affected by sound, and certain sounds that we may not hear may actually affect us anyway, and it affects our moods, the way we feel, it affects the brain function. So they may be experimenting with these on the people there to see what the reaction is. They probably have been doing it for years and years and years. And I actually think that they are using certain frequencies through the TV to control people through the television.
I tell you, we just bought a new one, and Lynn and I now know the damn thing watches us.
Yeah.
I mean, it really does. We've done our experiments. We know it's listening to us. And so we pretty much well assume that, it's watching us as well. And we can talk about a product and it will show up in our email or our banner advertising.
Oh my goodness.
Doesn't that give you just the warm and fuzzies?
Yeah, it's like 1984 all over again.
Yeah, and I think it's more, this is so, gosh, the word I'm trying to be Orwellian is the best way I know how to say. That's the best way, because there is no privacy. So moving on along, you and Scott came up with something that I thought was, I'm going to pull up.
Yeah, well, it was Scott who discovered this, and I just
way to go, Scott.
Yeah.
So there it is. I went there, and folks, you can pull it up yourself. You can go and so I just wanted to pull this up, let everybody know you can download it yourself. It's there.
Mm-hmm.
Whatever there is.
Yeah, so, it's amazing.
I'm going to pull up your paper, Claudia.
Okay.
And thought that we could go directly into that, because this is well, I could say disconcerting, but
yeah,
I don't want to be overreactionary.
Well, that reality is, of course, stranger than fiction.
Ain't that the truth?
Yeah, so basically,
some of the dates I had were stranger than fiction, but anyway. Okay, so moving on along.
Yes.
This is a family and an intellectual show.
Yes. So anyway, Scott found this image, and I thought it was very interesting because there's a lot going on in it. And so we see, first of all, that large object with the top portion, the northern hemisphere, is spherical. No, that big one there.
This one here.
So that's the one I looked at first, because you see, it looks like it's got this smooth surface on it, which I think would be plasma, and it's actually emitting light from it.
Look at that.
Yeah, it's amazing. And you can see that it's spherical. So this is obviously a spherical object. Yep. And it's got this probably most likely acquired atmosphere. It would have acquired it either from the sun or some other celestial object. And then it's most likely from the sun. It's now emitting light from it. That's not reflection. That can't be reflection. That surface, that object is not likely to be behind the sun. It's very large. If it was behind the sun, So it's in front of the sun, and it definitely has a bright spot that's facing the detector. So it's definitely emitting light.
Is there two objects in this one?
There's another one there, and Scott has another version of this image. You can clearly see that object is actually spherical. What we are actually seeing is a spot on it. That red, almost rectangular, is a spot on it that's brighter than the rest, but it's a spherical object. And so what we're looking at is all stellar cores. in the sun's outer corona. And then, there's the one at the top, and that one is in the right position to be Mercury. So I basically said, well, that the bright spot there, that's almost in the shape of a cross, that's Mercury. But it looks like there's something behind Mercury, because there's a circular shape behind it.
We can amp that up. And the other thing before I do that is that again, this is the sun. And
Yes.
people question you on, well, where's the corona? And you can just see that our sun is just weak. It's
Yeah, you can see how dark and this what this coronagraph shows is the outer corona. The inner corona only goes up to half the radius of the sun from the surface of the sun. So the radius of the sun is that white circle on the occulter. So we don't see the inner corona in this coronagraph. We only see the outer corona, which goes up to 12 radii from the sun.
Look at this, and this is Mercury.
Yeah, if you can see it, if it is Mercury, remember Mercury is a tiny, tiny planet.
Mm-hmm.
And the only thing we'd only see it in an image like this because it's very bright, right? So we wouldn't be able to see any shape around Mercury beyond that bright spot. And that bright spot would be the cross, right? So why is there an outline around it? Because there's something else there behind Mercury.
Yeah, and this is so frustrating with when you can't tell the depth. It's like there could be.
They do that on purpose.
Yeah, they do.
If you look at it, you can see that there's different colors there. There's a bright red, and then on the side, there's a darker black color. It's like it's a mixture of material. There are a couple of colors there. There's green and pink.
Well, we're really going to amp this up, and we're going to see. Here we go.
Yeah, there's lots of colors there.
There you go.
It's definitely not just Mercury. There's something there.
And you can just... it looks like it's almost got a backdrop of, a hue. See, now I want to see what this other object looks like. I think this is like 3,600%.
Yeah.
I feel like, oh, wow.
Look at that. And if we look below it, you don't see the spherical, you would expect the spherical bottom part of it to show up, but it doesn't, because I think there's a lot of debris around it, because some of what I saw looks like the debris that you usually see in the corona, which is, I've explained it to you before, it looks like a circle, a distorted circle with a dark center. And that means that it's a bright object in the sun's outer corona, but the telescope is defocused and misaligned.
Yeah, but what I'm looking at here is that, and this is what look at this. So the concaveness of the picture, and this is what I was looking for. This thing is big.
It's huge, yes.
It's
I just cannot be sure exactly where it is, how close it is to the detector. I cannot be sure of that in this case.
Little friend.
But it looks big.
I'll do my dinero.
Huge.
Holy crap! Oh, look at that!
Yeah.
Now,
that's a huge object as well. It's just not as bright because it hasn't gained as much of a captured atmosphere as the other one, plasma, or from the sun's corona, probably.
Look at this. What I'm seeing is you can begin to see on the distortion of the pixelation of an object that comes in. In this case, we can see clear pixelation on this one where we see literally pixels. Look at this. This is what surprises me on this little guy. This guy is round. It's round. You see the diffusiveness of how the camera is trying to begin to pick up. So this is round, Claudia. This is round.
Yeah. And I
Wow.
mean, once I have the image that Scott has worked on, you can see it's actually much larger. It's got a larger outline around it.
Well done, Scott. Well done. Well, let's go on. This is cool.
Yeah, it's
I
very.
guess it's
And
cool. I
then
don't
you
know.
can see there, just to the left of the object, you can see all the distorted rings with dark circles in the center, which indicates there's a lot of debris there. A lot of debris in the sun's outer corona.
Yeah, there
And
is.
there's some in front of the object because you see some of that just below that bright spot of that large object.
Wow. This one freaks me out now. This one's
Yeah.
really got my attention. That one is more spherical than, yeah, okay. Yeah.
It's amazing that we have so many of these objects there at the same time.
Tell Wayne I emailed him the pictures.
Oh, okay. Scott says that he actually emailed you those pictures.
Thank you, Scott. Thank you, my friend. Yeah, because I'm going to have a little fun with this. I want to go into Photoshop and
Yes, good.
you know.
You must send
Yeah, I
us
will.
that.
I'll send you and Scott that.
Yeah.
This one's got me all Twitter pated right here. This one, I mean, yeah, this is a big guy, but this dude,
It's fascinating that there's so many there at the same time.
So Claudia,
One
do you
image.
think that these two are conjoined to each other through a gravitational pull or a connecting force, or?
No, these objects have very little gravitational influence. Nevertheless, the sun is much stronger gravitationally than any of these objects are. They, even though they're large and have a lot of mass, they act as small, low mass objects in the sun's corona. But the problem is they energy absorbers. That's how they destroy. Yeah, Scott says you can open your email if you like. It will
Okay. While we're looking at this, I will.
Yeah.
So this is stereo A, and I was trying to get it right here so people can get an idea of what we're looking at. So do you suspect it's right in here?
No, stereo A is where that red letter is. It's
Right
looking
here?
at the sun, and you can see Mercury's aligned with
Right.
A and the sun.
Okay.
So that's what it's looking at. It's looking straight at the sun, and the Mercury is right behind it.
Okay.
So that object, it only sees a small width. It's very small width. The sun looks very large in that image. It would be like a little point of light in actuality. So basically, A is looking straight at Mercury, and the object will just be slightly to the left or slightly to the right.
Okay. So close. That's what I'm trying to get to. Close, right?
Close.
It is close.
It's definitely in the inner solar system. Let's put it that way.
Yeah. And I'm going over here to see. Okay, I just got Scott's email. Oh, wow. Okay, I see what he's doing. Okay. I'm going to tell you what. I will stop the share on this because Scott just sent me. Look at this. Holy sh. All right. So give me 1 second and I will pull up. Here we go. So here we go. Look at, there it is. Look at, there it is. I told you it was spherical.
Yeah, that's right. It's definitely spherical. Look at it. Absolutely obvious now.
Holy shit.
And it was that part that was dark around it that now we can see it's part of the object. And it's a very large object as well.
Oh, yeah. It's, what really unnerves me on this one, and here's another, look at that.
Yeah, look at that. That's amazing. Wow, yeah.
I knew it. That just, yeah, wow.
Yeah. These objects are real.
Yeah, and the thing about it is that, when you begin to see um these objects, I mean, look how big this baby is. I mean,
Hmm. It's huge.
it's huge. I mean, it's bigger than our sun, isn't it? Or is it
Yeah.
as, yeah.
And it looks even larger than it looked before. It seems to have another edge beyond even the bright spot that we saw, the bright part, the spherical bright part. And that's, yeah, it's almost like it has two layers.
Wow. When I saw this picture here, it reminded me of the 2001, the Jupiter spacecraft. Doesn't it look like it when you're looking straight? Anyway, I digress. But so I'm curious here, is it having an impact on the sun?
In this case, I don't see it. I don't see an interaction between the sun and these objects, to tell you the truth, which makes me think that they may not be as close as I have seen them. I don't see the sun reacting to them.
No, in fact, it's almost like the sun. I don't look at this, but this one here,
Mm-hmm.
I'm not an astrophysicist, and I'm not even a physicist, but
Oh, believe me, the astrophysicists would just close their eyes if you showed
of
them.
course they would. I don't see nothing. It's like that meteorologist told me, don't send me any more of your emails. I was like, hey, man, I'm just asking a question. But look at that.
Yeah, well, they've been, I've figured out they've been trained with lies. So
Yeah.
it's better not to ask them questions. They can't handle it.
Yeah, this is quite interesting.
It is. It's fascinating that these large objects are there. It's also fascinating as well that they're actually allowing us to see them. That's another question in itself.
Isn't it, though? It is. That's true. It's very true. And, I'm trying to I guess we could do the math on this, but I'm trying
The thing is, I cannot tell you how large it really is because I don't know where it is.
Yeah, that's just it.
That's the thing. If I see an object interacting with the sun, then I know it's close to the sun. I can do a size comparison with the sun. But when that's not there, I cannot. I know it looks large in the image. It looks fascinating and very interesting. But as to actual size, I cannot tell you.
Yep. Well, we know this one is spherical. I mean,
yeah, definitely.
Definitely. That one's round. Wow. Good. Excellent.
The thing is, the object behind Mercury, that one I can tell you may actually be larger than all the others. Because I know where Mercury is. Mercury was on the other side of the sun.
Mm-hmm.
So actually quite far from the detector. So if we have an object of that size at that distance, it's likely to be quite large.
Yeah, definitely. This is fascinating footage for me. I just it's concerning because if it's this close, which it certainly appears that it is, I mean,
yeah.
So, I keep thinking to myself, Claudia, cause and effect. We're seeing crazy stuff happening here on Earth. We're seeing crazy stuff happening to every planet, as is it's official, Neptune's out of its orbit. Why you don't hear that on the evening news, I guess it's just not good entertainment. It's like, hey, folks, we got a little problem in our solar system. So the new spacecraft that the ESA launched, I think it's called Peter. I wanted to bring this one up, Claudia, because I'm trying to get my head wrapped around. Now, they say that this is about 16 million miles out. This is part of the corona. They say that this is Jupiter. I'm asking myself, then what are these? Very defined.
I'm not seeing it, Wayne.
Oh, you're not? Oh,
Mm-mm.
okay. Oh, why did it not share? Let me see. Okay. Oh, well, it froze up. Can you
Oh
still
no.
see me?
I can see you, but the screen is black.
Yeah, yeah, it froze up.
Oh no.
I guess they didn't want us to.
Yeah.
Yeah.
Uh, you
Okay.
know how it goes.
Yes, it you and I get that a lot, don't we?
Yeah, we do. We do.
Yes, yes,
Yeah.
yes. So I'm gonna just be patient here and
Yes.
we'll just
Yeah, you may have to close the photographs that Scott
yeah,
sent you. Maybe it's just too much.
showing. Yeah. That's odd.
Yeah.
It never happens except on this.
Mm. Did you see the article I wrote on the moon?
I was going to be pulling that one up if I could ever get out of here. It's like the rat said, forget the cheese.
Mhm.
Oh man. So I am, what is
Well,
going
I could
on?
share it. I suppose I could find it on my computer and share it.
Yeah, it's
But it says Orwell Steiger has started screen sharing. So, but it doesn't show what you're sharing. So I guess I wouldn't be able to. Or maybe I could try. Should I try? Let's see. I have to find it.
am I back? I am back.
Yes, you are back.
No, I'm not.
Oh. Let's see if I can find it. Um, um, there we are. Fake moon. Okay. Okay. Um, right. So this is the article. Let's see. Let's make it a bit bigger. Right. So I had some things that Wayne has been telling me about the moon rotating. So I actually looked up for some footage, and someone had found it, had filmed the moon doing this type of rotation that many people have seen. And here we are. So this is actually from 2017, and this was April 13th, 2017. And starting at 1048, you can see that feature there, almost a large crater right at the top of the moon. And then at 1145, it had moved to there. So it had rotated a little bit. And then at 1:59 a.m., even more and even more and even more. By 3:20, it had done about at least a 30-degree rotation. So that means it rotated at a rate of 7 degrees per hour during this time. And this is what I call a phase rotation. And so the moon was rotating, doing a phase rotation. Now, the moon's not actually supposed to do this kind of rotation because of its actual tilt is actually only 1.54 degrees and its inclination is 5.14. So in total, it can rotate a total of nearly 7 degrees, or it can tilt during the course of one orbital period. That's 29 days. But that means it will tilt up to 7 degrees and then move back to its original position. So it should never get beyond this. Now, it just went from rotated 30 degrees within a few hours, 4 hours and 32 minutes. That's supposed to be impossible. So I then go through and I try to explain how the moon actually works. And if the moon didn't rotate, and you know that we never see the back of the moon, the backside, the hidden part of the moon. But if it didn't rotate, then we would see it, because say if you have a feature at the back of the moon, there it is, then if it does a quarter of its orbit from there to there without it rotating, now that feature is on the side there, it will become visible. So it will be visible there and there, and it's only here during its orbit that it's not seen. And remember, orbital period is 29 days. So for about a period of a week, you wouldn't be able to see that hidden part of the moon, but for the rest of the time you would. So the fact that we don't see it is because the moon rotates at the same rate that it orbits. So if it does a quarter of an orbit, at the same time it does a quarter rotation. And a quarter rotation means that that feature moves from there to there. So there it is. So that means by the time the moon gets there, that feature is at the back of the moon again, because it's rotated at the same rate that it orbits. So in other words, it takes the moon 29 days to do one full rotation. It takes the moon 29 days to do one orbit. So now, in order for it to do a phase rotation, what we have to have is the moon not rotating like this. And here what we have is the view from the North Pole. So this would be the moon's North Pole as well. We're looking at the moon's North Pole or from the top. And here we have the same view, but I don't show that rotation. I show the axis about which it would have to rotate in order to do a phase rotation. And now the axis is lying in the plane of the moon's orbit, that horizontal axis there. And that means that a feature on, say that would be the right side if you were facing the moon and were on the Earth, it would have to rotate up towards where the moon's North Pole is. That's how we would do a phase rotation. So this is what it's shown here. So it does a phase rotation. So that blue spot moves to the top where the North Pole is. Now, where did the North Pole move to? It moved to the side down there. It's now lying in the plane of the orbital plane, the moon's orbital plane. And the moon is going to rotate around the North Pole, which means that now that hidden side is going to rotate down under the moon until it becomes visible, because the moon did a phase rotation. So if it was possible for the moon to do this phase rotation, the hidden side of the moon would become visible. And the fact that it doesn't shows you that we're not dealing with a three-dimensional image of the moon. We're dealing with a two-dimensional image that is projected in the sky, and then it rotates. And here I just show where we can, from what time to what time do we see the moon when it's in its different phases. So if it's in a full moon, we can see it from sunset to sunrise. If it's three-quarter moon, we see it from midnight to sunrise, and then during the early part of the morning, and the quarter moon from the afternoon and all the way until midnight. And the new moon, if we could see it, we'd see it during the day, but because we don't usually see the new moon, because that side is not illuminated, we wouldn't see it at all. So, so the real moon is not supposed to rotate in the sky. It's supposed to stay upright. We're supposed to see it, say over here, if it's full moon, supposed to see it rising in the sky from sunset to midnight, and then sink down towards the horizon until sunrise. But it stays in the same position. It's not supposed to do a phase rotation. The moon's not designed. It's not supposed to, because then, as I said, you would start seeing the backside. But what happens is how you see it. It may look upside down, whether you are above the plane of rotation or the orbital plane of the moon, or above it or below it. So roughly speaking, and observing the southern hemisphere may see the moon as if it's upside down in relation to what an observer in the northern hemisphere would see. But it would stay the same as the observer sees the moon move in the sky for a whole night. It would never rotate. It should never rotate within one night. It's impossible. But what we do have, if the moon is a projection in the sky, then where we see a feature on the moon depends where the observer is. So if the moon is moved in the sky past a certain observer, then it would seem to perhaps rotate. But that usually happens from one day to the next, where the moon suddenly seems to be in a wildly different orientation from one day to the next. And this is why, because you have different observers here, and they all watching the moon, which is now a projection in the sky, two-dimensional projection. And so this observer here, the red one, looking at the moon, sees that yellow feature at the top of the moon. And the pink one sees that feature on the right. The blue one sees that feature at the bottom of the moon. And the green one sees that feature on the left. And that's because it's now a two-dimensional projection in the sky. When it's a three-dimensional object at 240,000 miles away, it always looks the same. But if it's a projection at cloud altitude, then it changes according to where the observer is. So this would mean that its orientation can change from one night to the next, because they just project it in a different position with respect to the observer. But what we saw there actually means that they rotated the screen itself, which is the sky that they're projecting. It had to have rotated in order for that feature there to move by, say, some 30 degrees. They had to rotate the whole thing by at least 30 degrees within those 4 hours and 32 minutes. So the conclusion is it's impossible for the real moon to undergo a phase rotation. And the fact that the moon's observed to do a phase indicates that it's a projection in the sky. So it's evidence that they are doing holographic projections of the sky. And this is not the only evidence I've come up with. As you know, there is much more. Okay, so that's it. Let's see if Wayne's back. Oh, he's not back. Well, I will have to... I can look at this one next. This is an article that I've just made a video on. It talks about these projections as well. And this is an image that Scott sent me. I think someone sent it to him. As you can see, the beach looks red here. It's very strange that the beach looks red, and yet we have a white sun just above the horizon. And then we have a yellow layer beyond the sun. But it's obvious that this beach is not being illuminated by white light. Why? Because it looks red. If it was being illuminated by a sun that's emitting white light, then the beach would look beige or white, depending on the normal color of the sand. But the water and the beach look red, and that means they are being illuminated by red light. That's the only explanation. So they're not being illuminated by, even if this is a simulator of this is supposed to be the real sun, obviously not illuminating this beach here. This beach is being illuminated by whatever light is coming from the sky above it, not by the light that's coming from there. That's impossible. So this suggests that what we have here is a holographic projection of the sky, or a simulation of the sky, and it's producing red light, and that light is illuminating this beach. And it doesn't even look like this is cloud that is emitting light, because this cloud looks quite dark. It doesn't even seem to be in the right tone, and we can see white, yellow, and red layers here. So this to me means that this is being illuminated by the holographic projectors that are just above this beach. And this means that most of what we're seeing here is a simulation of the sky. It's not real. Even the fact that it looks like there might be a simulated there, it's not real because it's not illuminating the beach here like the real sun would. So now we are seeing a lot of red skies, pink skies, and usually only seen at sunset and sunrise. But if the red and the pink skies were always due to Planet X dust, and a lot of the times it is, then you would expect to see it throughout the day. You wouldn't just see it at sunrise and sunset. So the fact that they are being seen at sunrise and sunset, and as I said, this is not real. This is the beach being illuminated by red light coming from the sky right above it. That can only be a simulation. So this means that they are actually allowing this to occur, actually projecting red and pink skies at sunset and sunrise. Why? Possibly because they want the population to get used to it, because sometimes they cannot stop it from happening. And here we can see a sky, and Wayne sent me this picture, and you can see this is obviously a holographically projected sky, and you can see the pink and the blue in it, and pink is featuring very strongly here. There's a lot of pink. So they actually are using pink lasers on purpose to produce a pink sky. And this is close to sunset because you can see this red glow here, which would indicate that the sun is close to the horizon. So this is close to sunset. And they were intending to produce a pink sky because they were using pink lasers to produce this.
Claudia, you have to share your screen.
Oh, I'm not sharing my screen. Sorry. Okay, sorry about that. All right, so sorry, I wasn't sharing my screen. So let's look at the image again. So this is the image that Scott sent me, and you can see the beach is red, the sea is red. You can see what seems to be the sun there, which is white. But if the sun is white, then it would be illuminating this beach with white light, and the beach looks red. So it can only be red light illuminating it. And it can only come from the sky right above the beach, which therefore has to be a simulation. It's not real. It's the simulators producing this red light, the holographic projectors in the sky. And this image is the one that Owen Steiger sent me. And you can see what we have in the sky, this regular pattern, which is obviously computer generated. and then it's projected onto the sky, and you can see the perspective of it going off into the distance. So this can only be a projection that was then photographed in order to show us this. It cannot be CGI. And you can see a lot of pink there. So it means they're using pink lasers. They're using pink lasers on purpose because they wanted to produce a pink sky, pink clouds. And it's close to sunset. And so they purposely were creating pink clouds in the sky. And so it means that they want us to see pink clouds at sunset. They want us to get used to it. Of course, we do see pink that is sometimes produced by the Planet X dust, and that's the case here. And this was what happened in China. They called it a sandstorm, but there was no sand swirling around. If there was sand, there would be, different areas with of different colors. Some would be darker, some would be lighter. That's what happens when you have a sandstorm. This doesn't look like a sandstorm. It looks like fog that is emitting pink light. So this means that this is formed around Planet X dust, and the dust absorbs energy, and that means that cloud that forms, that fog, absorbs light. And it reflects some and absorbs certain frequencies, and then it ends up looking pink. Pink is a mixture of pink, of red and blue. So that means it was absorbing mainly green light. You do see some green there. So that means it's not due to the simulators not emitting green light. There is green light, obviously, in the sky, but the fog itself is pink. So this is fog produced by the Planet X dust. But this over here is artificially created. It means that the powers that be actually want us to see pink skies at certain times, possibly because they want us to get used to it. And I think that's that article. And if Wayne doesn't come back, I think I will have to end it there. Let's see, stop sharing. And yes, I will say goodbye then for tonight.